So learning tutorial 14 is about systems of equations, and we're involving conic sections. So you guys have all solved systems of equations before. You did in Algebra 1 and you did in Algebra 2. All right? So you know the basic idea. We're not going to solve them graphically, okay, because we can't do that. Most of these in a graphing calculator anyway. And then we're not going to solve most of them using elimination. Sometimes they're set up to do so, but most of the time we're going to solve them just using substitution because it's the easiest method. Okay? Remember that when you're solving a system, you're looking for intersection points. So all of your answers should be in coordinate form, right? Shouldn't just be x equals or y equals. You should have give me a coordinate. So before we even solve anything, let's just think about the possibilities of what could happen. If you have a line and a conic section, well, then some things could happen. You could have no solution because they might not intersect at all. You could have one solution because they intersect one time. Or you could have two solutions because it could intersect twice, right? That's the maximum number of solutions you could have if you had a line and a conic section. Now, we could have systems that involve two conic sections. So if you have two conic sections, again, you could have no solution because they might not intersect at all. You could have one solution because they intersect at one place. You could have two or three or up to four solutions, though, because of how they intersect. All right? So keep that in mind, that you need to have all of the possibilities listed. That's not going to be hard to do once you figure out, oh, there's two possible x values or there's two possible y values, and I substitute that back in, and there's two more possible y values for that x value. You'll start catching on to how many solutions there are. There's not a surefire way for you to say there's going to be this many without looking at a picture, though. Okay? Just keep in mind that there can be multiple solutions. Although it's not super important in order to solve any of these today, I'm going to make you name what kind of conic section each one of the equations represents so that you're getting practice. Because tomorrow, you will have to know what kind of conic section it is, and you will have to graph it. So we'll have to do a lot of review with that tomorrow. So here are some basic things. We have four conic sections. We have a circle, an ellipse, a hyperbola, and a parabola. The parabola should be the easiest one to identify. Why should the parabola be the easiest one to identify? It's not a fraction, and also there's only one squared term, right? X squared or y squared, but not both. So parabola should be easy to figure out. You should be able to figure out the difference between a circle, ellipse, and a hyperbola. Hyperbolas are kind of separate in their own place because of what? There's a minus sign in the middle, right? So if you have minus y squared or minus x squared, you know you're going to have a hyperbola. So that leaves circles and ellipses. So what constitutes the difference between a hyperbola and, a circle and ellipse? If an ellipse is in standard form, it has to equal 1, and there's probably going to be fractions, right? If a circle is in standard form, it's just x squared plus y squared, or x minus h squared, y minus k squared, equals some value, okay? So you should identify which type they are. And if we do that today, that's going to start getting you thinking for tomorrow when we actually have to graph things. All right, so we're going to solve all of these algebraically. I'm not going to make you check them by graphing them. Okay, we're just going to solve them. So in the first example, you have what kind of conic section first? That was an ellipse. There's a plus sign in the middle. You have fractions. The second equation is not a conic section at all. What's the second equation? It's just a line. Now, just like when you solved systems before, you're going to take the easier equation and rewrite it, and then substitute that into the harder equation, right? So obviously, which one is the easier equation in this scenario? The line, the x minus y equals 0. That's easier. If you solve that, it turns into x equals y, right? You add y to the other side. So you have x equals y or y equals x, whichever way you want to write it. So because of that, it doesn't matter. You can substitute y in for x or x in for y. I don't care. It works out the same way. Okay? So would you rather have all x's in the equation or all y's in the equation? Because it's personal opinion. Let's do x's. That's probably a smart strategy because that way you have an x, you solve, and you can solve for y later. You get them in the right order in your coordinates. But it doesn't honestly matter in this scenario. So we're going to take the first equation. I'm going to rewrite it with an x instead of the y. I need to have one variable. I can only solve for one variable at a time. Like I said, there are multiple approaches to how to solve these. All right, my approach might not be your approach and vice versa. So I'm just going to ask you what step you might take next. If there's a problem with it, we can discuss that. But most of these I'm just going to say, what do you want to do next, and we'll do it. It's not. It's a 5. I was just writing a 20 from the first one, and so then I wrote it again. Okay, there we go. It's a 5. Right, so I was already thinking it. So maybe I was thinking it and trying to, put things on top of you. But if I was going to do this, I would try to add two fractions together. And you can only add two fractions if what happens? They have a common denominator. So that is one approach to that. So I was thinking ahead. It was fine. It wasn't actually finished, though. I just was already in the next step. So we can add two fractions of a common denominator. That's one way to do it. All right. We could also multiply by either denominator and try to reduce things. There's different ways you could do it. I think, though, if you had two fractions, you would try to add them together, especially when you know the top of both of the numerators are the same. So I think that's what you would do. So if I'm going to add these, I need to multiply the second fraction so that I have a common denominator. So what do I need to multiply it by? 4 over 4. All right, so if you multiply by 4, we get x minus 1 squared over 20 plus 4x minus 1 squared over 20. Now I have a common denominator, so now I can actually combine them. Right? Now, in the numerator, you have x minus 1 squared, then you have 4x minus 1 squared. So you can combine the numerator as well. What's the numerator going to be if you combine it? 5x minus 1 squared. All over 20. All right, I'm trying to solve for x. So again, there's two ways you go from here too. What would you like to do next? You could reduce. We can do that. 5 goes into 20 4 times. Then multiply by 4, right? We're cross multiplying because I want to get rid of the denominator. I'm trying to solve for x. So I get x minus 1 squared equals 4. Again, there's multiple approaches here too. So you can go for the longer approach, and you could FOIL this out and solve. Or, since it's just x minus 1 squared, we can just take the square root. All right? I'm going to go with the shorter approach. So we're going to take the square root. So I get x minus 1 equals plus or minus 2. Why is that plus or minus 2 super crucial? All right, it could be negative or positive, and since we could have multiple solutions, I need to have both of them. All right? If you forget one, then you're going to leave out a solution for this whole entire system. All right, so make sure that when you're taking square roots, you're thinking about that actively. Okay? So, almost done with this part. That means I have x minus 1 equals 2, and I have x minus 1 equals negative 2. That means that x could equal 3. What x could also equal negative 1. Again, almost done. We have the x's now. We're looking for intersection points though. So to solve for the y for each of these as well. In this case, so our equation is super easy. Our equation was that x equals y, if you recall. So if x equals y, that means if x equals 3, then y equals 3. If x equals -1, then y equals -1. So we're just going to write these as coordinates. So one solution is 3, 3, and one is at -1, -1. There are two possible solutions. A lot of math, a lot of algebra. But any questions about any of the things that I did? Okay. Make sure you're asking questions when I'm doing these today if you get stuck or you're lost. On the second system, there's a typo on your note sheet. It should say x squared plus y squared equals 16. I think it says equals 1 on your note sheet. My bad. So if we're looking at these, the first conic section is what kind? It's a circle. You have x squared plus y squared, and then it equals 16. So we don't have any fractions or anything, so we have a circle. And then the second equation, again, is just a line, because we don't have any square terms at all. Question so far? Again, if we're solving this, it's always smart to solve, if we're doing substitution, to solve the easier equation and substitute it into the more complex equation. So I'm going to solve x plus 2y equals 10. Then it doesn't matter. Again, it's totally up to you. But would it be easier to solve for x or solve for y? Would it be easier to get x equals or y equals? X equals. Because then I should just subtract 2y from both sides, right? If you're going to solve for y, you just subtract x and divide by 2, so you're going to have fractions. You can do it. It's totally fine. I just know you guys hate fractions. So I'm going to solve for x. Again, different approaches. You could have gone a different way with that. So if I solve for x, I'm going to subtract 2y from each side. So I have x equals -2y plus 10. So what should I do from here? Exactly. You're going to plug in -2y plus 10 wherever I see an x. So I have -2y plus 10 squared plus y squared equals 16. In this scenario, there is no shortcut. You have to FOIL that first binomial. It's -2y plus 10 squared. This is where people make mistakes. They're trying to go too fast. You cannot just do -2y squared plus 10 squared. You actually have to FOIL this. So first, what's -2y times -2y? 4y squared. Outside terms would be -2y times 10. That's -20y. The inside terms would be -2y times 10. There's another -20y. So that makes the inside term -40y. And then the outside terms, 10 times 10 is 100. Then I have this plus y squared still and equals 16. I have like terms, so I should combine those. So right now I have a quadratic equation. If I'm going to solve a quadratic equation in any way, shape, or form, what must the equation equal? has to equal 0, right? If you're going to do anything, it has to equal 0. All those things you learned in Algebra 2 and the different ways you could solve quadratics, also taught in Algebra 1, you have to have it equal to 0. So you subtract 16, so 5y squared minus 40y plus 84 equals 0. So, again, doing lots of algebra today. There's 3 ways that you learn, there's more than that, but 3 ways that probably come to mind when you're trying to solve a quadratic equation from Algebra 2. 1, you could graph the equation, right? You graph the equation, you're looking to see find the x-intercepts. So if you're going to go that route, you can do that. 2, you can factor it. This isn't looking very factorable, or if it is, it doesn't look very nice because there's a 5 in the front. All right? So that would be pretty complex factoring there. All right? So we don't want to do that. 3rd is the quadratic formula. All right? Graphing this one is totally acceptable. I'm going to do the quadratic formula just to make sure I remember what it is, just because I haven't seen it maybe in a year. So I'm going to remind what it is. But graphing it is also acceptable here. Okay? So remember, to solve something with a quadratic equation formula, it's y equals negative b plus or minus square root of b squared minus 4ac all over 2a. So if we did it this way, we would have positive 40 is negative 40 plus or minus 40 squared minus 4 times 5 times 84 all over 2 times 5. You should always do this part first. Because it tells you how many solutions there are for the quadratic. Right? If you get 0, there's only 1 solution. Because you're doing plus or minus 0. If you get a positive, there's 2 solutions. And if it's negative, you get no solution. All right? So I'm going to focus on what's underneath the square root. 40 squared is 1,600. And 4 times 5 times 84 is 1,680. So I'm going to get the square root of negative 80. What does that mean is going to happen? Can you take the square root of negative 80? No. So that means there are no solutions to this quadratic equation. I don't have to do the rest of the formula. I mean, I already know there's no solution. You can't take the square root of negative 80. We're not looking for imaginary numbers here. We're not trying to find imaginary solutions to conic sections. All right, it's not happening. All right, so there's no solution. So I don't have to do anything else for the rest of the problem. Y doesn't equal anything, so then x can't equal anything. There's just no solution at all. All right. If you looked at a graph of this, because you could have typed this into your calculator, you'd have done 5x squared minus 40x plus 84 in your calculator, and it wouldn't have crossed the x-axis, so there wouldn't have been any solutions. Again, that was why it's totally acceptable to do that as well. I caution you against graphing because if you get these decimal values as your intercepts, I'm going to want them in exact notation, like with square roots, and not as decimals. Okay? But again, it's always a good way to check. You at least check how many solutions you're going to have. Any questions about that example? Okay. The other 2 examples I have today have 2 conic sections in them. Okay, instead of just a conic section in a line. So the next one. What is the first conic section? What kind of section is this? First one's on a circle. Hyperbola. There's a minus sign. What about the second one? Circle. All right, now, You can solve this using substitution. That'd be totally fine. All right. This one also is set up to do what, though? Solve using what? This one's also set up for elimination. It's almost perfectly set up here to multiply one thing, and you could start adding or subtracting. All right. So because of that, I'm going to do it both ways. All right. I just want to show you, or at least I'm going to start it both ways. I'll solve it one way. But that way you can see how much work you would have to do in either way. Again, I don't care. I generally, in my notes, I'm going to solve every single one of these using substitution, just because I was in the habit of doing that, so I did every single one in substitution. And I might make different steps than you would have made, and you probably could still get the same answer. Again, there's ways you could diverge in your work on all of these. Okay. I'm going to do this one using elimination, though, because I think it's shorter. And then I can set up the substitution if you want to see it. All right. So if you're doing elimination, remember you have to have two terms somewhere that match so you could add or subtract them and make that term go away. So currently you couldn't do that because there's not a 9x squared or a 4y squared in both. Okay? So I need to multiply the second equation in order to eliminate. I can multiply it by 9 or I can multiply it by 4. Again, it doesn't matter. I think the smartest way, since you have a minus sign and you have a plus sign, would be to multiply by 4, because then you'd already have it set up. You could just add them together, and the 4y squareds would go away for the time being. Okay, again, that's not the only way to do that, though. So I'm going to multiply this equation by 4. Okay, you multiply the entire equation. So you have 9x squared minus 4y squared equals 36 from the first equation. And you multiply the second one by 4, so you have 4x squared plus 4y squared equals 16. I'll figure out both of them. Because the signs are opposite, that means I'm going to add the two equations together. So what is 9x squared plus 4x squared? 13x squared. And then negative 4y squared plus 4y squared, that becomes 0y squared. So that's 0. And what is 36 plus 16? 52. All right, so we divide by 13. What's 52 divided by 13? 4. Then how do I solve for x? Take the square root. Again, remember you have positive and negative 2. So I just need to pick one of the equations. I would pick one of the original equations. Probably x squared plus y squared equals 4. I need to solve for y. So I would have one version with positive 2 squared, one version with negative 2 squared. Yes, they're going to come out to be the same thing, but you have to remember there's two different solutions. So I just always at least set it up to make sure you know what y is going to be. So 2 squared is 4. If you subtract 4, you get 0, so y is 0. The same thing is going to happen on the second equation because negative 2 squared is also 4. So I have 2, 0, and negative 2, 0 as solutions. Quick note, because the last one doesn't take very long. So quick note, again, you could have solved this system using substitution. It would have been fine. So if I had chosen to do that, I would take x squared plus y squared equals 4, and I would solve for x squared or y squared. You don't have to solve for x or y, because there's an x squared term and a y squared term in the first equation. So I could just solve for x squared and substitute whatever I had in for x squared. Or solve for y squared and substitute whatever I had for y squared into y squared. You don't have to solve for x or y if that's not what you have, as long as the variables match. So if I had done this substitution-wise, I would have had x squared equals 4 minus y squared. And I would have just changed the x squared term in the first equation. So that's another approach to the problem. You get the same exact answer. Okay? Questions on the third example? All right, on the last one. What is this type of conic section at the top? X squared equals y. There's only one square term. So it's a parabola. And then the second equation is one of those fancy hyperbolas that I put on the quiz as a bonus question on the hyperbola quiz. So it's not like vertical, horizontal, would have happened horizontally, or sorry, diagonally. We don't have to worry about that right now, but that's what that equation is. It's an equation of a hyperbola, right? Now, in this case, the first equation is already solved for us. It says x squared equals y. So we really have y equals x squared. So everywhere I see a y in the second equation, I can just put an x squared. There's nothing extra to solve. So what's x times x squared? X cubed. And how do I solve x cubed? Take the cube root. If you take the cube root of 1, is that positive and negative 1? It's just positive 1. And so then we can put that into this other equation. Y equals 1 squared, so y equals Now, there's going to be lots of different things that happen in these homework questions. And homework's not due tomorrow. But you could get an equation that has like y to the 4th plus something y squared plus something. You might have to factor. You might have to LOIF, but you don't have to use 4th power, so it'd be squared and squared. You could use the quadratic formula. You just square everything. Lots of different things you could do. That's why I want you to be working on them in class so you can ask questions, or working on them at home so you can come in and ask questions, because they're not the easiest problems in the world. Let me get into them. Okay? Any questions about the examples I did today, though?